Hello, this is Zhao Zhang in Civil Engineering in San Francisco State University. And today we're going to talk about the shear and moment diagram under concentrated moment. And here is the simplest supported beam. We have a concentrated moment categorized 20 kilonewtons meters, adding in the middle of the beams. And we're trying to find the reactions and draw the moment and shear diagrams for this beam. As we learned from the previous videos, before you can do all of those, first thing you need to do is to draw the free body diagrams, which basically is taking out the supports, replacing those with the reactions, and trying to find the reactions, and then we go from there. And since we don't have horizontal force, we know that AX is equal to 0, and we only have AY and BY. Now let's first try to solve the reaction for these beams. We can do that by sum the moment at 8 using clockwise as our positive directions. And with that, you're going to have your BY because it's going to create a counterclockwise moment that is going to be negative BY times the moment arms, which is 10 meters. And we're also going to have this negative 20 kilonewtons meters moments, external moments. Since the AX and AYs are passing through that point where we're taking the moment, therefore the moment for those two loads are equal to 0. And with that, we can find that our BY is equal to negative 2 kilonewtons. Let me write it a little bit clearer. Negative 2 kilonewtons. The negative means the direction of the force is in opposite direction of our assumptions. We're assuming the force going upward. This negative tells us the force is actually going downwards. Therefore, we can put that, or your BY is equal to 2 kilonewtons, but it's going downward. And if we summed the moment at B point, because the equilibriums, the summation is going to be equal to 0. What we have is we're going to have this AY times the moment arm 10 meters. Subtract this 20 kilonewtons meters is equal to 0. Therefore, our AY is equal to 2 kilonewtons. And it's going upward. We can check our answer by checking to see if the force going upward is equal to the force going downward. And the force going upward, we're going to only have the AY, which is 2 kilonewtons. And the force going downward is the BY is 2 kilonewtons. They're the same, so we can confirm that the answer we're getting from above is correct. And that's one way to solve the reaction. There's another way. Since on this beam, we only have a concentrated moment counterclockwise, and we have two forces. These two forces need to create a force couple to resist the external concentrated moment. The external concentrated moment is in counterclockwise, therefore the force couple is needed to create a force couple that will create a moment clockwise. Therefore, we need to have the AY going upward, the BY going downward, and the magnitude of those forces are equal to this external moment divided by this moment arms. Therefore, in another way, what we can do is your AY is equal to the negative BY, denoting their force couple in the opposite direction. And that's going to be equal to the external moments, 20 kilonewtons meters, divided by the moment arms between those forces, which is 10 meters. That will give you 2 kilonewtons. Right? We're getting the same results as what we go through. Therefore, this method is also valid. And in order to find out the shear and moment, we use our typical method. We cut the sections. For this case, let's cut the sections at 1 meter. And we have the AY is equal to 2 kilonewtons, and this is 1 meters. On the section being cut, we're going to have our shear, axial, and our moment. To find the shears, we can sum the force at the y direction going upward as positive. If we do that, we're going to have this 2 kilonewtons minus V is equal to 0. Therefore, your V is equal to 2 kilonewtons. And if we sum the force in x directions, we know that our end is equal to 0. To find the moment, what we can do is we can sum the force at this point. Let's say this is our C point. If we sum the moment at C point using clockwise as positive, equal to 0, what we're going to have is this 2 kilonewtons times the moment arm, 1 meters, clockwise direction, therefore that's positive, minus our M is equal to 0. Therefore, your moment is equal to 2 kilonewtons meters. And that is in the counterclockwise direction because we are calculating, the answer is positive. Our assumption is counterclockwise, therefore the moment we found is counterclockwise. And we can cut the section for the whole beam, and due to the time, I did that for you. So this is X meters, and here is our shear in kilonewtons, and here is our moment in kilonewtons meters. All right, and first that is 0.001, 1, 2, 3, 4, 4.999, 5.001, 6, 7, 8, 9, and 9.999. All right, the shear you're getting is 2 for all the cases. And the moment is 0, 2, 4, 6, 8, 10, negative 10, negative 8, 6, 4, 2, 0. And if you put those back to the plot under your members, and here is what you're going to see. Your shear diagram is going to be 2 all the way, and your moment diagrams is going to look like this. And that is our tent for a different point. 1, 2, 3, 4, 5. Your moment is 2, 4, 6, 8, 10. All right, let's take a look at this shear and moment diagram and see what we can observe. Observation. The first observation, if you look at this, the shear diagram, your concentrated moment doesn't have any effect on your shear diagram. Your concentrated moment does not have effect on shear diagrams. That is the first thing that we see. And if you look at the relationship between the shear diagram and your moment diagram, you can see if you calculate the area at this point, x equal to 1 meters, the area for this shear diagram is equal to 2 times 1. That's equal to 2. If you calculate the area at x equal to 2, that area is going to be 2 times 2 is equal to 4. That's happened to be equal to the value of your moment diagrams. Therefore, the second point, from left to right, the area of your shear diagrams is equal to the value of your moment diagram. The third point, if we calculate the slope of this moment diagram, the slope is equal to delta y divided by delta x. Delta y is 10. Delta x for this is 5. That's equal to 2. That's happen to be equal to the value of your shear diagrams. Therefore, the third observation, the slope of your moment diagram is equal to the value of your shear diagram. That's the third observation. The four observations, at the location where you have a concentrated moment, the moments diagram have a dropped. The concentrated moment, we create either a drop or jump at the moment diagram. If your concentrated moment is counterclockwise, that you're going to have a drop. And if your concentrated moment is clockwise, you're going to have a jump. And the moment drop is equal to, this is 10, this is 10. If you add those up, it's equal to 20. That's equal to the value of your concentrated moment. And if your concentrated moment is counterclockwise, and that is going to be a drop. If your concentrated moment is going to be clockwise, that is going to be a jump. And the drop and jump, the value is equal to the magnitude of your concentrated moment. Okay, this is the shear and moment diagram under concentrated moments, and I'll see you next time.